Hey guys, welcome to my channel. This is your host Kunjan Shinde. Today, let us design this spectacular electronic circuit which is meant for controlling street light automatically. Consider this as a hobby project. Let us begin with the block diagram. In the block diagram we can see that it consists of 4 different blocks. One is the power supply unit, one is the sensor unit, control unit and the LED. The power supply unit is responsible for generating the necessary current and power for the other circuitries. So here, in order to implement this automatic street light control circuit, we are making use of a LDR, light dependent resistor, or we can make use of a photodiode. So by this one we can sense the amount of light that is falling on the sensor, and based on this one we can trigger the LED or the real time street light. Here the control circuit is nothing but a comparator circuit which compares the reference signal and the sensor output. If the sensor output is high or low, based on that the control signal is been generated. Let us look into the circuit diagram. We can see that there is a 9 volt DC battery which is given to the 7805 regulator IC. Here the 7805 regulator IC converts a 9 volt DC to a 5 volts constant DC supply. In order to indicate this supply, we are making use of a LED and a 560 ohm resistance. Now this output of a regulator IC is given to the LM324, which is a comparator IC, to the pin number 4. Pin number 11 is grounded of LM324 to the first set of comparator, which is at pin number 1, 2 and 3, where 1 is the output, 2 is the inverting input and 3 is the non-inverting terminal. So at these inputs we are connecting the reference voltages and the sensor input. So the reference voltage is being designed by 5.6 kilo ohm resistance and a 10 kilo ohm preset. So this defines the variations for the voltage on inverting terminal, whereas the sensor is connected on the non-inverting terminal from pin number 3 to ground via 10 kilo ohm resistance connected to VDD. This will create a voltage on non-inverting terminal. Based on the presence of light and the preset value that we are going to set, it is going to generate the output signal. Assuming it is a night time and the LDR sensor is not able to pick up any source of light, so what happens here is the pin number 3 is going to get a high signal, as the LDR gives a high resistance which offers a direct path from VDD to pin number 3, making the pin number 3 non-inverting terminal larger than the inverting terminal potential. By this way the output of this circuit will be plus 5 volts. This can be given to a relay or to a LED in this simple project to indicate the presence of street light. As soon as the light falls on the LDR, the resistance of the LDR is going to decrease, thereby the voltage on non-inverting terminal is going to reduce, and hence the output becomes low. In this second circuit, I have made use of a relay to convert a real-time bulb. So in this one what we are going to do, we are going to drive the output of LM324 to a base of a transistor. Here I am making use of a BC548 NPN transistor, where it is going to make a ground connection for the coil 2. Relay here that I am using is a SPDT which has 5 terminals, coil 1 and coil 2. Coil 1 is connected to the plus 12 volt supply, whereas coil 2 is connected to the collector of the transistor, and the emitter of the transistor is grounded. As soon as there is a positive voltage on the base, the collector is going to be connected to the emitter and thereby connecting it to the ground and energizing the coil. Once the coil of the relay is energized by this mechanism, the output is going to switch from normally connected to the open circuit. So by this way the AC signal is getting connected, and hence the bulb or a lamp is turned on. By this way we can control the same circuit for a real-time application by introducing a transistor and a relay. Now let us look into the components required. So we have a SPDT relay here, which is of 5 terminals as explained earlier. You can go through the configuration and look into the understandings for a relay. So with this I am making use of a BC548 transistor whose pinout has been shown here. You can refer this. Hey guys, like and share this video with your friends and colleagues. Let me know what you think about the video in the comments below. Do subscribe to my channel for more updates. Now let us look into the practical implementation of automatic street light control. You can verify the functionality of the automatic street light control by observing this video. So in this video I am making use of a LDR. See, when I bring my hand closer towards the sensor, the presence of light is been decreased and thereby it turns on the LED. Once I remove my hand, you can see there is a light that is falling onto the sensor. This way the LED is off. By this way we are able to switch the LED on and off by looking into the brightness on the sensor. In real time we need to make use of a transistor and the circuit shown in the figure above so that you can implement it for real time application. This is a very handsome project that can be done within a very low cost of 50 to 100 rupees, provided that relay is available with you. These are the list of components required. Thank you all.